Hello, everybody, and welcome to our Improving Dust Collection in Cement Plants and Mine Applications webinar. Thank you so much for coming. Welcome to the more than 120 that sign up in LinkedIn and also more than 50 that register in our website to attend the Zoom broadcast. So thank you so much. I am Andy Biancotti. I'll be your moderator today. Maybe you know me from other webinars that we've held in the past. But yeah, we're very happy to have you with us because this is a topic that matters a lot to a lot of facilities in both cement and mining, manufacturing, and dust collection is connected to everything in a plant. It's connected to safety, to emissions, the maintenance of the equipment, the uptime of the production, and the overall plant performance. And so being acquainted with these systems, it's really, really good for everybody in the plant. The information we're going to cover is based mainly on the questions that we receive from plant managers, mining process engineers, maintenance personnel, and operators. But also, it's based on the plus 40 years of experience that Baghouse has on dust collection in the cement plants and the mining applications. In the past, we've worked with companies like Lehigh Hansen, Cole Portland, Bootsy Cement, Ash Grove Cement, Holcim, Quick Creek Cement, Oldcastle Aggregates. And also in mining, we've worked with Goldcorp, Musselwhite Mine, Platinum Crush, US Silica, GMA Mining, USA, Stillwater Company, well, and many more. So throughout the years, we have accumulated a lot of knowledge, and we want to share that with you today. A few announcements before we begin. This webinar is going to be interactive, so if you have any questions or as you listen to some of the information covered, a question comes up, write it down in the chat box, and at the end of the webinar, we can answer it in the Q&A section as time allows, right? Also, after the webinar ends, we're going to send you a copy, a recording of the webinar in case you want to rewatch some of the sections. And if you like to invite someone right now to the live webinar, we're going to copy the link to this Zoom meeting so that you can share it. Maybe you can send a message saying, please connect right now. We are going to be happy to welcome everybody. All right, so what this webinar will cover. So this webinar, I will cover the cement manufacturing process, the mining process, where dust is generated in both of these applications, why cement dust is different from ordinary dust, the technologies that can be used these days, some considerations regarding safety and combustible dust, and also best practices for selection, maintenance, and optimization of dust collectors. And we have here experts, Matt Coughlin, who is the owner of Baghouse.com, and also Dominic Del Santo as well. So they are both going to have a part in this webinar. All right, so we give our attention to Matt Coughlin as he presents Introduction to Cement Manufacturing and Mining Processes.
All right. Thank you, Andy. Welcome, everyone, for joining the webinar. So we've got some really good information to share. I'm going to start with an introduction to cement manufacturing and mining processes. So regardless of where you work, if you're on the mining side, if you're in cement manufacturing, hopefully you will find something that applies to you here. And, I'm hoping to address your specific questions as we go through the whole process here. So keep in mind, good dust collection starts with an understanding of the material flow, because every major transfer point, crushing, grinding, storage step can create emissions. The application is slightly different as you move from one side of the process to the other. So it's important to understand that process and how we approach it from a dust collection perspective. So, a lot of dust collection problems happen when a system's selected around just generic airflow sizing instead of looking at the realities of the process, right? So the next few slides here, I'm going to map out where dust is generated, along the process and how we can, connect that to our dust collection sizing and application, specifications to address your dust collection problems. So let's start with the raw materials. So, in your side of the process, wherever you're at, what are the raw materials in play? So, in cement manufacturing, typically it starts with a mix of raw materials, primarily limestone and clay, with gypsum or other supplementary material like fly ash or recycled cement dust that might be mixed in or added depending on the product later on. So it's worth taking a moment here to think about what am I dealing with in terms of raw materials? What is the dust at my part of the process? Because each material behaves a bit differently in the dust collection system. So some materials, maybe in the crushing process, are coarse and abrasive. That dust is treated a little bit differently than a really fine dust or a hot dust that might happen later on in the process and might be more prone to carry over, floating around the facility or the site, building up on your equipment and your floors and so forth. So this is one thing that we look at. One reason why filter media selection, air to cloth ratio, hopper and hood design, discharge equipment, all these things that we look at need to be tailored to accommodate the specific material. And we're going to talk about some of those things in more detail later. But understanding the raw material helps explain why, cement dust isn't just one single dust type, and explains why, the solution to the dust problem at your process might differ from one side of the process to another, depending on the material you're using. So now let's look a bit at the cement manufacturing process. And this might be, very fundamental or obvious to some of you who live this process day in, day out. But as I go through this, I'd like to maybe think about like where in the process are you focused? What stage of it are you working in? And, we can hopefully provide some answers that are specific to your process that'll help you. So starts with crushing and pre-homogenization, right? So you're taking the limestone rocks and crushing them up. And so you've got a stacker reclaimer systems may help homogenize materials. So basically just big crusher systems. Then you're going to raw material preparation where you're grinding this, rough material into a raw meal. You've got your cement mills, processing materials and classifying them to the proper size prior to kiln feeding. And at this stage, typically you're talking about finer dry powders, ambient temperatures, but significant airborne dust potential because you've got crushing, you've got conveying, you've got chutes and so forth, transfer points where dust is moving from one point to another. Each one of those process points and transfer points will create dust. So after that, you've got your clinker production where you're, going into preheater and rotary kiln. You've got materials that are heated to very high temperatures. Clinker nodules are formed. You've got hot gases and fine particulate leaving the kiln, which require effective gas cleaning. So at this point, we start looking at dealing with temperature and potential chemical challenges. So you can't just have a standard dust collector with, a 12 gauge sheet metal enclosure because you have really high temps. And what happens to those high temps when they cool down below the dew point? You have moisture forming in the baghouse. Moisture and cement are very bad. That we run into the risk of having, that dust hardening into cement inside your baghouse hopper or inside the ductwork or inside your rotary airlock. And all of those things can present real challenges. So if that, clinker production phase, high temp is really kind of the driver for our design considerations. So we have to deal with that with insulation, heaters, and so forth. And then we grind up the clinker, mix it with gypsum to make cement. The final cement fineness is tied directly to your product quality, right? So we want to make sure that we're collecting dust that and not product off the line. So it comes down to hood and duct sizing and so forth. Grinding, conveying stages produce a lot of dust as well. So anytime you have a classifier or shaker or things like that where you're moving around your product, you're dumping it onto a conveyor belt. Every one of those points is going to create dust. So you need a properly designed capture hood, you've got to have properly designed ductwork, and you have to have a dust collection system that's sized and designed for that stage. And then finally, you've got your packaging and loadout where you're, pouring your product into a train car, a truck car, or into super sacks or packages or something like that. Those are, of course, really, common places for dust to be created. So all those transfer points and loadouts and stuff need their own specific dust collection, design around them. Next slide, we can take a look at the same process with a little more visual detail. So you can see from limestone extraction, crushing, through raw meal preparation, preheating, kiln processing, clinker cooling, final grinding and sizing, and then packaging and shipping, right? So which part of the process are you focused on? If you're, primarily concerned with the loadout and packaging and shipping, then it's good to know what those transfer points in your part of the process are. Where is dust or where is product moving from point to point, from a conveyor into a silo, up an elevator, and understanding which of those transfer points require dust collection. It'll probably be most of them. And at that phase, what kind of dust is being produced? What's the components of the product and the dust at those points in your part of the process? What is the sizing and the quantity of material being moved, and how do we design a system to capture dust correctly at each point? So the best designs for dust collection follow the material and gas stream. So it's not a one size fits all template. It depends on which part of the process we're in, because you've got all these variables, right? The dust raw material content, we've got the dust particulate size. Is it fine? Is it coarse? What's the temperature? All these things come into our system design. So when you come to us to help you with your system, those are the first type of things that we'll start to ask. Where in the process is it? What's the material? You have info on kind of the material size, the temperature, and so forth. So major dust sources in cement plants. So every part of the process has its own, typical dust producing points. So the biggest dust points are, so we've got quarry and crushing operations, right? You have typically you're dumping raw material, rocks, and very coarse material into conveying systems. So every time that conveyor at the head box of the conveyor, or the tail pulley area where it dumps onto the other conveyor, you're going to have a dust plume. It's very common to see a dust collection system going to those points, which is just a duct, like a straw into the box. So without much consideration of the vent design at that point, which is actually critical, because once dust escapes the enclosure and becomes airborne, it's much more difficult to deal with. It requires a lot more energy to collect and filter dust out of a large volume than it does to collect dust out of an enclosed area. The airflow requirements go through the roof. So each one of these points, similar approaches. So transfer points, loadout points, anytime dust or material is moving from a conveyor or being blown into a silo, all of these points, you can see where the visual emissions are. So in your part of the process, where do you see the emissions? You can probably walk your part of the process and find where your visible dust emissions are. Most commonly, they're going to be at all those transfer points. Again, kiln, exhaust, and cooler applications, they add some complexity because now we have hot product and hot dust. And so what happens when that's not done properly is you have the same type of dust emission problems, right? At every transfer point, you're going to have dust being produced if it's not captured properly. Now you have hot dust, which is settling in places. It may be cooling. You might see moisture and condensate. And then you have hard cement dust around your process and your facility. And if the system isn't designed correctly, you'll have, moisture mixing with cement dust, and you'll have all kinds of problems. So that's why we like to look at these in kind of a process by process lens. So let's take a look at the mining process for a second. So, mining, we're starting with drilling and blasting, loading and hauling. So this is, out in the quarry or in the mine, you may not have dust collection. Usually the dust, ambient dust problems down in the quarry, on the roads leading up to your initial processing is done just by, putting water down on the roads and cutting down the, opportunity for dust to get kicked up by your trucks and stuff. But once you get to primary crushing, then we're looking at a dust collection system type of application. So you're getting rock crushed. It's creating dust. Usually it's very coarse dust. And, we might be looking at potential cyclone pre-separators or big bag houses that are sized very conservatively uh, because they're heavily dust loaded. Secondary crushing and screening, again, you're getting smaller and smaller particle size. Um, you're looking at shaker tables and classifiers and so forth. So usually this type of equipment has its own kind of pre-configured out of the factory dust collection ports. So we're just running our ductwork to the shaker table, and we're going to meet your OEM specs for the size of that. But if not, we need to design a proper hood or a capture hood or something like that to capture the dust. Where possible, we want to be enclosing it so it's not just open air. Any escaped dust should be captured so that we can get it to the dust collection system. It doesn't float across your facility. Um, let's see, conveyors. Again, at this point, you're going to start using a lot of conveyors. You've got elevators, and there are basic design standards for how we create vent hoods and size ductwork and size the whole system around those points. So it's going to depend on the size and type of your conveying systems, the room available and the head box of your conveyors and so forth. But once we have a pretty good idea of what that looks like, we can design a system with pretty high confidence based around that. So when you first come to us, it's really helpful if you have a engineering layout or the drawings of that process so that we can size and design the system to match it. Again, major dust sources in mining operations. Look at your operation. Where are you seeing the dust? And again, it's going to be material handling, transfer points, bag unloading, silo filling, where you're using screw feeders, conveyor transitions, transfer chutes, weigh hoppers, batching lines, enclosed loading stations. All of these are potential dust sources, and they all require some special attention. In this case, a lot of the special attention goes into the hood design and the ducting design. If we're talking about ambient temperature dust, the dust collection system itself, we size based on our standard sizing guidelines, but where the system, the make or break decisions come down to the capture point. Transfer chutes and conveyor transitions are especially important because they require, their enclosures, poor enclosure or bad airflow through those can really just let dust spread throughout your facility. So let's keep that in mind. Finally, so enclosed or underground loading stations also require special attention because if you're indoors, you have a ventilation balance to keep in mind. You also have operators. Oftentimes they'll be down there exposed to that. So if you're at a bulk loader, you're going to have an operator down there. You don't want him being dusted and exposed to, respirable dust. So if you're pulling dust collection air out of a facility, we also have to consider the balancing of the facility. So we don't want to have the doors slamming shut because we're pulling 60,000 CFM out of the facility and we're not recirculating it or making up that air. You can also be pulling dust in from outside. So that's usually we would look at recirculating air through the dust collector back into the building or have some sort of a makeup air unit to make sure that the ventilation balance in the building is neutral. So think about your facility. Do you have any of those issues? Are you noticing that when you go in, the door slams behind you? That's a balancing issue. And then next slide here. So, why are the dust collection systems so important? And what does it matter if it's dusty? It's a dusty process, right? Well, there's a number of things. So first off, workers' health, right? You have employees out there that are potentially subject to exposure, respirable silica and respirable fine dust. It's terrible for your lungs. You don't want your people to be subject to that, right? So adequate dust collection will mitigate that. Equipment protection. You don't want your equipment being caked with cement dusts or prematurely failing because of design issues and so forth. It costs a lot of money. You're investing a lot of capital funds and putting this equipment up. You want your process to be up and running, 99.9% of the time. You don't want unplanned downtime because, your dust collector is clogged up or the duct work is full of dust and you need to replace it or open it all up. All of these things have major financial consequences for like a cement operation where you're trying to churn out product every day. Product recovery and cleanliness, dust emissions, if there's dust all over the place, you may have product that's being contaminated by dust with material you don't want. So that's important. Um, Environmental regulatory requirements. We all should be familiar with the basic MSHA and OSHA requirements, exposure limits, and so forth. So, plants have to comply with those requirements. If they don't, you run the risk of being shut down or paying fines and all kinds of things. So nobody wants that. And then overall, operating costs. So if you're an engineer and designing a system, you're going to have to submit your initial CapEx funding request. It's a big project expense up front. But overall, on top of that, you have your maintenance. How often are the filters going to have to be changed? What is the downtime? What type of energy cost are you consuming, with compressed air, with your fan power? All of these things come into play. So it's very important that when you go to design your system or redesign your system or refurb your old system, whatever it is, that all of these things are kept in mind. And that's why we take kind of an overall system approach. We dive very deep into the details to make sure that the dust collection system we use is perfect for your application. Okay, and so for the next section, I'm going to hand it over to Dominic Dal Santo, our sales director, and he's going to talk about dust collection technologies that are used in cement and mining.
Thanks, Matt. So now we're going to go over dust collection technologies that we often find in cement and mining plants. Now, some of these you may find at your facility, others you may not, but we're going to review all of them so we get a good overview. In many plants, we see there's a mix of legacy equipment. You might be familiar with these or other systems, but you might be surprised that they might not be the best for your application. It might be holdovers from an earlier time when the technology was less advanced, or might just reflect older ways of doing things, or perhaps just were a less than optimal choice at one point in time that over the years, the reasons why certain things were put in has kind of been lost. But we're going to give a general overview of everything, and that will kind of help us to recognize perhaps where we have deficiencies that we can improve with either new technology or simply by redoing something with the appropriate solutions. So let's start with our dust collectors. First type of dust collector that's very common to see in mining applications are cyclones. So cyclones are a type of mechanical separator, mechanical dust collector, so there's no filters inside. A similar device would be something like a classifier, but also knockout boxes. There's a bunch of these mechanical separators, mechanical dust collectors in use, but they all pretty much do the same thing. They remove dust by having the dirty air enter the dust collector, spin around or impact some plates inside, and that sudden change in direction of the air, as well as in the cyclone where it spins, the particles eventually hit the outside of the cyclone wall, and then they slow down and they fall out of the airstream. And then the air exits and goes out somewhere else. Now, most cyclones are used as pre-filters, and this is because even the most advanced cyclone or multi-clone or whatever you might have, it will not remove enough of the dust for you to exhaust it straight out to the atmosphere according to environmental regulations. So you can't just use a cyclone. However, in mining and cement, we often use them not just to lighten the load before it goes to the dust collector with the baghouse. Well, in some applications, we use them to separate material by size. So depending on how we size and use the cyclones, but we can get a certain range of particle sizes that are removed. Say, for example, we have a mix of different particles from very fine, but we have a lot of material that's, let's say, 50 to 100 microns in size. We want to use that for something. So what we might do is size the cyclone so that it only removes particles in that size range and lets the fines continue on. A very common application is a Raymond mill, where you'll usually have a very big cyclone that sucks up all the material that comes out of the Raymond mill. Perhaps it's not been milled down to the right size. And then it's removed and put right back into the Raymond mill to keep processing it. And then we bleed off some of the air from the cyclone that has the fines in it, so the material that's gotten smaller than we want, and that goes to the baghouse. It's a very common application or usage for cyclones in the mining and cement industries. So again, good for pre-filters, remove most of the dust, and oftentimes are paired either for some process reason, but often are just used to lighten the load, the dust going to the baghouse. So moving on to the next most popular kind is the baghouse. So baghouse dust collector filters inside. These are used exclusively because they're the only modern system that will allow you to take in anywhere from a small amount of dust to an immense amount of dust and then exhaust the air out to the atmosphere and comply with environmental and safety regulations. So the baghouses are just one kind of dust collector that has filters in it. That's the most common. You also have, as we'll see, cartridge collectors and pleated filter bags that go in baghouses. But baghouses are found on everything you can see in a mining or cement plant, from dryers, conveyors, crushing, refining, milling, as well as transportation. Various forms of baghouses are present in all those different spots. Let's see now, a detail here is the type of filters we use in the baghouses. So as I said, we use fabric filters in the shape of bags in the baghouses. The most common materials we make the bags out of are going to be polyester. And then for temperatures that are a little higher, I think dryers, kilns, things like that, we're usually going to see aramid bags or Nomex bags. So the polyester bags are good up to about 265 degrees Fahrenheit. As long as we're under that temperature, we're pretty much going to use polyester bags exclusively because they're the cheapest, the most robust, and the most widely used, and least reactive. If the temperature exceeds that, then we're probably going to go to aramid next, which also is very robust. And then in certain cases, if the temperature is above 400, which is about the limit of most aramid medias, then we might go up to something like fiberglass bags, which are more delicate. So we have to take some extra precautions if we use fiberglass bags. For example, we have to use special cages that have extra wires on them for fiberglass. But these could be used on some dryers and kiln applications. We'll have to take some extra precautions. Now, in certain spots, you might have a mix of chemicals, moisture, humidity, different things going on where you can have acid reactions. Now, in these cases, we might use a different medium that's especially resistant to those kinds of chemicals, things like acrylic bags, or maybe bags made out of PTFE felt. Now, a very common, I'd say the three most common additives or treatments we put on top of the filter media. We take, if it's polyester, aramid, or fiberglass, whatever the base media is. Very commonly, we will apply on top something that is a acid-resistant finish. We'll also apply a hydrophobic, oleophobic coating that repels oils and waters. And then in many cases, where we need to collect a higher percentage of the absolute smallest particles, or if the material we're collecting, for example, is extremely toxic, highly regulated, whatever it might be, then we might apply on top what's called a PTFE membrane. This is different from PTFE filters, where the bag is made out of the PTFE. And it's not just a spray coating, which unfortunately we've seen some manufacturers start promoting the same way. PTFE membrane is a separate filter material that's made and then laminated to the surface of the filter bags. And it has the effect of capturing more of the smaller particles and allowing for the dust to release more easily. So these are just a few of the common filter medias you'll see in the baghouses. And if you see in the slide here, what you're seeing is a mix of bags that are folded, the wire cages that support them, and then next to those, you see pleated filter elements. These are a special kind of filter that we can put in our baghouse. We'll come back to that in a sec. First, let's go to the next kind of dust collector that we often see, which is cartridge collector. So cartridge collectors, this terminology is important. Cartridge collectors use cartridges instead of bags. Excuse me. Use cartridges instead of bags. So instead of a bag that's 6 inches by, say, 10 feet long, the cartridges are usually 12 to 18 inches in diameter and maybe 20 to 40 inches long. This picture here you'll see is a standard horizontal design where the filters go in horizontally. Others use vertically oriented filters. But in both styles, they basically mimic the baghouse where you have dirty air comes in, captured on the surface of the cartridge, and then clean air exits through the back of the cartridge collector. Just like a baghouse, it's just rotated the orientation a little bit. Um, the cartridges work very, very well at collecting at a high efficiency, so getting very fine medias. And they're generally cheaper than baghouses because we're packing a lot more filter area onto the cartridge than a typical bag. One cartridge, for example, has the equivalent amount of filter area because the filter is pleated and jammed on there. One cartridge has the equivalent of sometimes like 10 to 20 filter bags. Now, the downside of this is that because it's all jammed on there tightly, it's a little bit more difficult to clean the filters, and they can't quite handle the same dust loading or the amount of dust coming in as the baghouses. So we often use the analogy the baghouse is like a big heavy pickup truck that you can do everything with. You can go off road, you can carry people, tow things, drive on the highway. Cartridge collector is more like a van. So if you're just carrying a lot of volume, light materials, big empty boxes, the cartridge collector, like a van, is a more practical system to have. In mining and cement, we don't see them used so much because most applications for mining and cement have a lot of dust that comes in. Cartridge collectors are especially good when we have a lot of air to clean that has a little bit of dust in it. In those applications, they absolutely make sense, and they can be a lot cheaper than a baghouse style. Now, there are some differing opinions. A few manufacturers recommend them for cement and mining applications. Most in the industry, however, decide not to use them. If you are going to use them in a mining or cement application, we do recommend you use the other style where the cartridges hang vertically, as opposed to this style you see here where they're horizontal, because this can have problems where the dust builds up on top of the filter and it can't be cleaned off when there's a lot of dust coming in. Now, if we go back to thinking about the baghouse filters, we expressed about the pleated filter elements here. So a common way to get the benefits of a cartridge collector in cement and mining is to take a baghouse and then use these pleated filter elements. So these pleated filter elements are a type of cartridge that is designed to retrofit into a baghouse. So they have some of that where the media is pleated and jammed onto the filter, so it has more filter area than a bag, but it's not jammed so tightly like the cartridge collector cartridges, where you get a lot of the problems where the dust can't be removed and things like that. So usually we see these retrofitted into existing baghouses, but sometimes we do new systems with them as well for mining and cement. More often they're used when we have bin vents or small systems as opposed to a very large baghouse. But absolutely something that you should investigate in some of your applications with someone like us to see if it's a viable option, because there's a lot of benefits to switching to the pleated filters in your baghouse. Now, moving to the last kind of collector we'll discuss, which is when we have just a silo to vent or an enclosed space, we often use what are called bin vent dust collectors. So here you see a picture of one. Bin vent dust collectors are basically just baghouses that have the bottom section cut off, have the hopper section removed. So that's why they look like 2/3 of a baghouse. Everything else is exactly the same. They have the same filters, the same cleaning mechanism, the same controllers. Where they are used differently many times, though, is whereas a baghouse usually is pulling air from something with its own fan, bin vents are usually placed on top of something where you're pushing air or pushing material into. So the most common place is on top of a silo, or sometimes weigh bins or very large day bins. And the reason we put them there is because as you blow air in with dust, it displaces the air that's already in the silo, and it needs to be vented out. So if we didn't have some kind of bin vent dust collector, two things would happen. Either the vessel would start to pressurize until it pops open, or you would pressurize it and then the air and dust would go backwards through the loading line. So we have to have some way to vent the air out while leaving the material inside. So most common setup, a big silo, where when the trucks or trains come and they blow the material in, or you have a big screw conveyor that drops material into a silo, on the top of the silo, you have a bin vent dust collector. As the air is displaced, it goes through the filters and out the dust collector just like normal. Sometimes they have a fan that helps pull the air through. Sometimes they don't have any fan. So only the air being pushed in is what goes through out through the bin vent. Other times it's both things. The air is being pushed in as well as the bin vent has a fan pulling out. But in either setup, it essentially work the same way as your normal baghouses. A lot of times these are the most neglected and overlooked dust collectors in the plants because they're often very hard to get to. They might be used intermittently. And because of that, it's hard to monitor them. It's hard to check and keep them in good condition. So a lot of problems with silos, with loading, unloading, these kinds of things. A lot of these come from not having the bin vent either sized correctly or maintained well. So they're definitely an area when we go and do inspections and system audits, it's definitely an area where we see a lot of plants lacking and where they can make improvements. Now, just the last area we'll talk about is material conveying. So material conveying is used in many different parts of plants, cement and mining. Most commonly for these applications, you'll have some kind of screw conveyor that moves the material around, so mechanical means. You might also have a belt conveyor or maybe drag conveyors, other things like that. But a lot of applications within the plant, you're going to be using pneumatic conveying. Now, when you have pneumatic conveying, you're taking material and you're blowing it or pulling it through basically a small piece of ductwork. We usually call it piping to another space. So in these systems, like we said with filling the silos, for example, you might blow material from your truck that comes with material to deliver, blowing it up into the silo. That's pneumatic conveying. Or you might, from the silo, have it go down and load the truck or a barge or a train car. In that case, you're also doing material conveying, pneumatic conveying. So dust collectors in these kinds of applications, you see them, sometimes they're in the form of bin vent silos, like we said. Other times you'll have round dust collectors that are called filter receivers, where you blow to them, or maybe they're a vacuum system pulling. These are essentially just baghouses that are round so they can handle higher pressures. But these systems, for all intents and purposes, function the same way as normal baghouses. Sometimes as well, when you have lots of screw conveyors, these, depending on how they're used, usually need some kind of dust collector hooked up to them to pull the air through because they make a lot of dust. So your screw conveyors, your bucket elevators, your discharge points between the belts, if you have a lot of belt conveyors dropping one to another, all of these spots, you usually need some sort of dust collection at that source in order to avoid having fugitive dust emissions coming out. So looking at your material conveying is often where a lot of the dust collection needs in your plants are going to be. Now, if we go to just a few points here about system design considerations, some of the most common things that we get asked that come up with regards to mining and cement applications are these. Source capture. In general, the closer to the source of the dust that you can put the pickup of the dust collection, the better it's going to be. If you try to vent a large area, it quickly becomes impractical. The same dust collector that has 1,000 filter bags that can handle your dryer, if you try to vent a single room, can only handle perhaps a room that's 20 by 20 and only pick up light dust. Whereas if it's with hoods and ducting going right to the source, that same dust collector can handle dozens of pickup points throughout your plant. So we almost exclusively need to do dust collection at each source where it's generated. A few things with ductwork design. Ductwork in general is the thing that takes the most amount of engineering and time when we're designing a system. People think it's the baghouse or the dust collector, but often I'd say 80% of our time and efforts go into designing the ductwork. And a lot of the problems that happen in older cement and mining plants are because the ductwork over the years gets changed, modified, neglected. And each time it's changed a little bit or repairs are done in a less than ideal way, it's the death by 1,000 cuts. And that's how you end up with a lot of the problems at these facilities are because the ductwork is not ideal, not so much the baghouse. So designing it correctly in the first place, but also understanding the importance that ductwork is not simply connecting hoses to things. There's a lot of engineering that goes into it. And you may need to review the system you have in its current state in order to see where it's deficient and then make changes. But basic principle we want to get across is that ductwork changes are something to be done only in consultation with a dust collector or mechanical engineer, dust collector expert or mechanical engineer, because there's a lot going on there. We talked a little bit about filter media selection. In general, we want to make sure we're selecting the best filter media based on the temperature, but then also if there's things like moisture to take into account, other chemicals in the gas, also the particle size and the dust loading that the system sees. All of these play into what kind of media we select. Another thing that comes up often is centralized versus point of source collection. So centralized is where you have a single dust collector that's connected via ductwork to many different dust sources. This is the standard type of system. Point of source collection is where you have the dust collector built into the thing making the dust. Now, in older plants, this was done a little bit more often, I would say, than in more modern plants. So you might see older dust collectors built into, say, a really big screw conveyor or on certain belt conveyors. This approach has mostly fallen out of favor because the kinds of collectors that you can make so small and stick on the belts and all that really are not ideal. They don't function well. So a lot of best design practice has kind of abandoned that approach. There are still a very few moments where you'd want to do that, but in general, the larger centralized system is going to be the way to go. And that doesn't mean that you have one massive dust collector that collects from all over the plant. It's generally better to have one collector for a certain group of sources. You know, maybe one handle all the conveyors in one part of the plant or one room, for example, or on the dryer, things like that. But those are still centralized systems in that they use the ductwork to pull the dust back to the dust collector. And then another common thing that needs to be looked at is hopper design. Make sure that we have a sufficient design that allow the dust to be removed and not get stuck in there. So that may involve using things like vibrators or aeration devices to keep the material flowing and emptying out of the baghouse. But also, whatever comes under the dust collector, so the rotary airlock, and then whatever's underneath after the discharge, we need to consider that as part of the entire system. Many times people think of those as different things, but a lot of the problems in cement and mining applications with dust collectors can be traced back to the discharge underneath. It goes into a screw that goes over here. That backing up or not being sufficient to remove dust quickly is a cause of a lot of the problems we see. So you have to think of all of it together. The ductwork, the hoods, the ductwork, dust collector, the discharge underneath where it goes, as well as the system fan, obviously, all of that together as one dust collection system. And by doing that, you can avoid some of those problems. And then finally, one last thing that we often see when we do inspections is the cleaning system setup. Most, if not all, modern dust collectors in these applications are going to be pulse jet style, where they pulse the filters with compressed air. Many, many times we find plants where they have it set on cleaning just on timer mode. So just clean the filters every 30, 60 seconds, all day, every day. And this results in a lot of over cleaning, wasted compressed air. The over cleaning wears out the filters much faster than they otherwise would. It's a huge waste of resources of compressed air. Plants sometimes get nervous thinking that if they do something else, it won't be sufficient and the system will back up. A much better option is to have it be a clean on demand system where the system automatically cleans when the differential pressure is high and then shuts off when it's not. Because they're often neglected or not set correctly, plants think that those systems are unreliable. So they prefer to just keep it on the timer setting. But they're really doing themselves a massive disservice by doing that. Better to fix the problems of neglecting them as opposed to just ignoring those kinds of systems. We find in many cases where plants are wasting tens of thousands of dollars in compressed air, as well as dramatically shortening the life of their filters because they just have it on a timer setting. So it certainly is worth the effort to put the clean on demand there and then to maintain it well so that you can see the benefits. Okay, lastly, just a few things we want to mention with maintenance, monitoring, and optimization. So every single dust collector in your plant should be equipped with a differential pressure gauge, and it has to be working. It's one of the most tedious and most routine things that we can do, but it's the first thing we mention whenever we do a visit is making sure the differential pressure readings are accurate and reliable. If we don't have that reading, and we can't rely on it and trust it. It affects everything we do with regards to maintenance, operation, planning. So we absolutely have to make sure that that system is functioning correctly. This might mean cleaning out the gauges, cleaning out the lines, either weekly or bi-weekly, or installing a device that automatically purges the lines and keeps them clear and clean. But if we don't have that information, we can't make any intelligent decisions about maintenance and operation. So we have to monitor it many times as well. Simply upgrading the gauge from a basic magnehelic gauge, which is just a mechanical gauge you look at, to one that has a 4-20 output will allow all of those readings, especially those far-flung bin vents on the top of the silos that takes 20 minutes to get to and up a 150-foot ladder, sending that differential pressure reading down to the control room via 4-20 gauge for the extra $50, $80 it costs, was an incredibly wise investment. So making sure those are monitored at all times. And it's also easy to access, reduces a lot of unnecessary labor. Then you're going to obviously want to monitor for any leaks or emissions, whether it's coming out of the dust collector, coming out of the exhaust stack, but also in the plant where you might see fugitive dust coming out of some of the sources. If it's not collecting enough of the dust and the dust is getting out, that means there's a problem somewhere. Other things you can monitor if you really want to try to optimize, especially on your larger, maybe your key systems, how much compressed air you're using, the pulse valve performance. You might also want to have something that's monitoring that dust is being discharged through the airlock on the bottom, things like fan vibration, RPMs. You can also monitor emissions coming up to track the life of the filter bags. All of these things can be done on any unit, but we recommend them particularly on your most important units, your crushers, your dryers, anything that's permitted, because that's where you're really going to see the most benefit from it. And then finally, a lot of things that cause poor performance in the dust collectors can be traced back to shortcoming in the maintenance plan. So using the wrong kind of filters, letting them run too long, not taking care of these basic regular maintenance tasks. But some of it comes back to design flaws. So things like using the wrong filter media, undersizing the dust collection system, not designing the hoods or the source capture very well, or as we said, modifying it over time, adding more pickups, diverting things around, butchering, chopping up, and pasting back together the ductwork. Also, though, things like not having the dust collector settings correct. All of these kinds of things affect greatly performance elsewhere in the plant. So if you have a dust collector where you see a lot of dust forming at the pickups, or it's just dusty in your plant, you have to look at the whole system and find out where the problem is. Not often just that the baghouse is not doing well. It's often a victim of other things. So being able to diagnose and troubleshoot problems from a systemic perspective is really essential to making sure that you get the best performance out of your systems. Well, further on that, we're going to turn it over to Matt now. He's going to go over some of the best practices that we see for cement and mining facilities. Matt?
All right. Thank you, Dominic. So just to kind of summarize from the presentation today, so there's a few important points. Number one, the dust collection system should be designed around the actual dust source. So it can't be, or it shouldn't be just a generic airflow number, CFM, and run with the dust collector. The reason is the hood design, the material behavior, the source dynamics at your particular part of the process are really important to making sure that the dust collection system performs as you expect it. Filter media is extremely important. So depending on where in the process you are, what type of material you're collecting and conveying, and the process parameters, heat and whatnot, the filter media can make or break the performance of your dust collection system. So temperature, moisture, abrasiveness, particle size, all of these things we talked about can influence the correct filter media for your dust collector. We may even want to have a cyclone pre-separator in front of it. So another thing to keep in mind here is that, process changes are often unavoidable, but when your process does change and you move the equipment around or you add something, you take something away, that may invalidate the original design basis for your dust collection system. So, if you have an older system and it's not performing as it should, it's likely that some things have changed over time. The system balance is different. The system, the processes connected to the dust collection system may have changed. So, if you're looking to retrofit a system, optimize it, you may need to go back to the drawing board to make sure that the sizing, the vent, capture, vent design, and all these things we talked about may need to be reevaluated to make sure that that system is properly designed for the current state application. If you're planning on making a change to the system, it's worth looking at all those factors, maybe bringing us in as a consultant or a helper or just a sounding board to evaluate, if we add this duct branch over to this new process, what is it going to do to our dust collection system? And then, we talked about the maintenance and inspection requirements, putting in proper maintenance checklists and so forth to make sure your pulse valves, your diaphragms, your controls, your compressed air, their filter condition, all of those components are properly maintained so that you have a good dust collection system that will work for decades and give you the performance you want. All right, so in the next slide here, we're going to talk about a couple of case studies. I'm going to talk about silica mining, which is one that I worked very closely for the last couple of years. So we have had a couple of silica mining customers that we've worked closely with. In particular, in the last couple of years, we were approached by one company with a nationwide footprint. They've got dozens of plants around the country doing silica mining and processing operations. So the initial, request was because of the PEL limits, the product exposure limits were changing. There's national mandates changing the PELs. And they wanted to know, where they were at as far as benchmarking the dust collection and the dust emissions in their plants and figuring out what they could do to make sure that they're compliant and their people are safe. So silica dust in particular is, there's a high hazard of respirable silica, which is, can cause lung disease and cancer and all kinds of things. So it's very important in silica plants in particular that, these dust emissions limits are taken seriously. So what we did is we put a plan together. We visited dozens of their sites, did a very thorough layout and mapping of each dust collection system. Some sites have, a dozen or more dust collection systems on the site. So we mapped them out. We did a current state layout and evaluation of the dust collection systems. Looking at all the factors we talked about, dust emission sources, hood capture, ductwork design, dust collector, filter media, sizing, maintenance, the whole 9 yards. And for each site, we submit a report with our findings, basically saying, here's your current state dust collection system layout, kind of a basic engineering document for each system with a list of recommendations that, would help improve the site. So we've worked with them to implement some of those. And they've been able to implement a lot of those themselves as far as maintenance, equipment modifications, and so forth. A couple of the very common things we saw from site to site was, number one, because silica dust is highly abrasive and a lot of these systems are years or decades old, there's a lot of degradation just due to abrasive dust wearing through ductwork, vent hoods, enclosures, and dust collection, equipment. So although the system might have been designed properly 15 years ago, now that there's holes worn in the duct elbows from the abrasive dust, and you've got holes worn in the, the housings of the dust collectors, they're having performance issues. So what we did is we walked through the entire system for each of these, documented where you're losing your airflow and suction to these, holes and degradation. Things have been moved and changed over time. The systems are totally out of balance. Sometimes the dust collector is undersized or oversized or not properly configured. So, that's basically a blueprint that we can then hand the customer to say, if you want to address the dust emission sources that you could see, if you want to make sure your exposure limit, requirement is met, and if you want to follow the best practice to make sure that you have dust collection under control at your site, here's your blueprint for what to do, step-by-step checklist, and then it's gone to work implementing that. So That's the Silica case. We've got many others like it. I'm going to let Dominic talk now about a couple of his experiences with gypsum and frac sand mining.
Yeah, thanks, Matt. Yeah, I thought we'd mention just three specific customers, different industries that highlight some of the benefits that we can bring to our customers. Over the years, we've worked with many frac sand plants. There's been a lot of consolidation over the years, but we've worked with close to a dozen different frac sand companies over the years, some of them combined and things like that. So the landscape has changed a lot, but we've been to quite a few. We've helped a lot. A lot of common things that we've been able to help at some of those facilities, in addition to training. Many of them we found, especially as they consolidate, they have a really hard time maintaining a standard list of parts, in particular their main filters and cages for their baghouses. And unfortunately, a lot of manufacturers and then mostly sales rep organizations that provide filters as third or fourth parties even. A lot of times they have an interest in keeping the end user in the dark a bit about the types of filters that they use. A kind of really common thing that gets done is they just give you a very generic part number that says nothing. And then when you go to reorder the parts from someone like us or another bag or cage manufacturer, it's this big process because you don't actually have any information about the sizing of your filters. So a lot of what we've helped these companies to do has been to standardize the internal descriptions that they use. So instead of just having a part number, making sure you have an accurate filter and cage description. And what I mean by that is one that has all of the information necessary for someone like me or somebody else, if you want to take your business and get quotes elsewhere or keep us honest, has all of the information you need that they can quote exactly your filter that'll fit perfectly without having to do all kinds of tests and measurements and things like that. So that would be for a bag, it would be including the top and bottom construction that you have, mentioning if you have things like wear strips, double bottoms, all those kinds of things. Complete description of the media that you have, weight of the fabric, as well as the fabric media it is, and any treatments or finishes that you have. And then for the measurements, it's for most common, which is a snap band style bag for top load baghouses. It's the diameter or the flat width of the bag, the length of the bag, but then also the exact size of the tube sheet hole where it snaps into. And a lot of times that information is missing, and that's why we have to do sampling, all these kinds of things. So having all that information there for the bags, for the cage, having the true cage diameter, the length, the number of wires, the type of metal that is used, whether it's galvanized or some kind of coating or stainless, as well as the top construction, and making sure that those two things actually go together. Sometimes they drift a little bit through inaccurate measurements and reorderings, and you get a bag and a cage that are mismatched. They fit together They fit together, but they're not close enough in size, so the bag is loose or the bag is tight. So helping people standardize that has helped a lot of our frac sand customers to reduce their costs because then they can easily get quotes from multiple manufacturers, but also their plants and their managements across all the different plants can quickly order and know that they have exactly the parts they need. So we've been able to help them with that and getting bulk discounts, having things on hand and stock for them. A lot of the frac sand industry, it's a quick running industry, so they need stuff quickly. So being able to get them parts quickly, replacement filters and cages, which usually have a long lead time, being able to get that to them quickly has been a great benefit for them that we've been able to supply. Moving to cement, one of our customers we worked with for many years, Cal Portland Cement, at several of their facilities. Something particular we did with them, for many years we did service work for them. So we conducted the filter changeouts on many of their large reverse airbag houses. For example, their large plant in Mojave, California, a couple thousand reverse airbags needed to be changed with big J rods and springs and things like that. So quite a big production. But something that we found after doing inspections and providing recommendations and things like that, they just didn't have the manpower or the management structure available at the time to really implement a lot of the recommendations that we would make. So something that we offer to them and we offer to other customers is to actually have regular preventative maintenance program from our company. So it's not that we would completely replace their maintenance department, but rather we come periodically to do certain maintenance tasks. And sometimes we tailor the program to more so our people come regularly to do inspections and then make the list of preventative maintenance projects for the next quarter or year for their people. And then we do regular follow-ups to help them implement it. Sorry. In the case of Cal Portland, what we did was we actually assigned two of our people to be there for several weeks at a time every quarter. And they would come, inspect, make a list of most important repairs that were pending. And then with the customer, we would work out what we should focus our team on while they were there to make the best use of their time. And this was very useful. In fact, for a number of years, we had people permanently stationed at one of the plants there to help them to get caught up on a lot of maintenance things that had backed up in their baghouses. And they found this very useful for them because they were able to check off the list just a huge amount of tasks that we had pointed out to improve operation on all kinds of different systems, dozens of different dust collectors they had at their plant. So that's one way in cement where you often have a lot of different collectors, all kinds of different things. It's you can get inundated with small things that need to get done or medium-sized projects. So having our team come in and just help with those or just give guidance to the in-house maintenance can be really useful. And then lastly, I was thinking we could mention drywall and plaster production. So one of our large customers is United States Gypsum. And what I really like about our relationship with them, the benefits we've been able to give them is through our training partnership with them. So a number of years ago, we established through corporate offices a plan to offer comprehensive training and inspections at their plants. So we worked out some favorable terms for them, some discounted pricing, as well as as well as putting them at the top of our priority list for training dates and things like that. And to date, we've been to, I believe, about 10 or 12 U.S. gypsum plants with more scheduled. And each time we go, we've been able to do a multiple day visit with inspections of all the dozens of dust collectors they have at the plant. And then after taking that information in, the following days when we do the training with people, we've been able to incorporate directly into the class our findings from the inspection. So this lets us then, as we're discussing the material with the people from the plant, we're able to reference real life situations that are happening in their plant. You can say, oh, see this, where this applies on unit number 5, this same problem is existing. You see the connection? Or it also has helped us to get feedback from them to further enrich our reports that we provide, providing then the management with a report that really reflects what actually is happening on the ground, what personnel actually see and believe and think and understand about the different processes. And this has helped them to implement a wide range of changes to improve efficiency, to cut down on costs, and really to increase production in many areas as well, improve reliability ultimately. A few other things that we've done with them in particular plants. We're working with one plant in particular to change many of their bin vent dust collectors. They have dozen or more different manufacturers and legacy units, designs in their plant, which makes finding parts, maintenance just a nightmare. So as we've been replacing them, we've made a concerted effort to make sure that all of the bin vents are the same design and take the exact same parts, exact same filters, exact same pulse valves, controllers, all these kinds of things. And it's taken a lot of effort to do that because the bin vents are different sizes, capacities, but we've been able to standardize the design. So now, instead of having all these different things they have to try to figure out, they have one set of parts that goes to multiple systems, and everything is improving dramatically. And then just one other common thing that we've seen actually in all of these customers, many, improving the filter ordering, gauge supply. Like I said before with the frac sand, having so many different random patches of orders and things like that from over the years and not having clear part descriptions led to a lot of different ordering and just all kinds of different inefficiencies with cost, with lead times, with the quality of the product, with the fit of the product. Because we're a manufacturer, because we work directly with the plants, we've spotted a lot of problems when reviewing the orders of filters and cages, for example, that a lot of people just take the order or the information, quote it, and sell them the same thing over and over again. Because we're looking for ways to improve things, we many times found mismatches between the fits or areas where we could switch to a different media, either to improve things Or in a few cases, actually, with some of the plants we found where they were using a more expensive filter media than they really needed for a lot of the units. So we were able to, go down to a much cheaper fabric and save them quite a bit because it simply wasn't necessary for the process that they had it on. And then lastly, a big thing that we've been implementing with their help at a lot of the plants is the importance of having the dust collectors clean on demand, so pulse when the filters need it based on differential pressure. A lot of plants had moved away from it from bad experiences back to just having it on timer setting, which wastes a lot of air, which overcleans the filters. A lot of bad comes from that. So we've been able to build their trust back in that system and how to do it correctly and move them back to that. But also we've been working with what we call removing a lot of clipboard data, which is people having to go around and physically write down the differential pressure of the baghouse and do that multiple times a day or a week and physically write something down, physically put it somewhere, physically type it in. We've been able to help a lot of the plants to make monitoring remote without being a huge investment and to centralize it so that it all goes to one place. And then that one person that used to just exist just to do that can now go around and actually do preventative maintenance or do inspections. Much more valuable use of that person's time and the plant's resources just by moving to automated and remote monitoring. So those are just a few of the things from some of the different customers that we've worked with. And a lot of those we find at, I would say, the vast majority, if not all, of the facilities that we visit when we do our technical inspections and training. And that's why we recommend that service so much, because we really find really specific issues and help plants not only identify them, but then lay out a very viable way to overcome them. Well, with that, I'll turn it back over to Matt.
All right, thanks for that, Dominic. As kind of a summary slide here, I'm going to talk about how we, baghouse.com, can help you at the customer, wherever you happen to be, whether you're on the mining side, on the cement processing side, engineering, maintenance, operations, EH&S, safety, whatever, what we can do to help you. So we have a number of services we offer. We talked a little bit about how we've done technical audits and inspections at some customer sites. That's something that we do very often when a customer comes to us with questions or problems. So do you have problems at your site? Do you have dust accumulating, visible dust emissions? If you're not quite sure where to start or what to do about it, we'd be happy to do a technical audit. We send out one of our technical people out there to map out your system, document all the issues, and make recommendations so that you can attack those on your at your facility. System design and troubleshooting, similar thing. So, if you're not getting suction where you think you need it, all those kind of things, we have a whole staff of technical people, engineers that are happy to help with those problems. Filter and media recommendations. If you send us your filter spec for what you're currently using, maybe you've got a cartridge collector out in your facility, you're having to change the filters every month, and you're not sure if that's good or bad or what you can do about it, send us whatever information you have. We'd be happy to take a look at it and make sure that you're using the correct filter media. Of course, we sell filters of all types and configurations, and we're happy to sell those or just help you out if you have questions. Retrofits and upgrades. If you have older equipment at your site, we do a lot of upgrade work where we'll go out and we'll rebuild a dust collector. We will redo the duct work and capture hoods and make sure that your older system is brought up to current standards. So that's something we offer. We do maintenance programs. We have maintenance contracts with customers all over the country where we will go in quarterly or monthly or on an as-needed basis to perform scheduled maintenance for your equipment. So that means filter changes, just general PM checklist inspection type work, rotary airlocks, changing your diaphragm valves, the whole 9 yards. Whatever you need, we're capable of doing that, including larger filter change outs and so forth. Safety and dust hazard. So we can come out and evaluate your system. We can take measurements and provide reports to help you address your compliance requirements, whether that's respirable silica or, exposure limits, or if you have combustible dust hazard on site, we're happy to do that. In addition to, basic, dust collection system design and integration, installation, and so forth. I think that pretty much wraps it up. I'm going to give it back to Andy to tee up the Q&A, I think.
All right, great. So we have the Q&A section now. We have 14 questions that our attendants have submitted. The first one, we have this one's for Dominic. What is the difference between a baghouse and a cartridge collector for cement applications?
So as we explained earlier in the webinar, they're both excellent dust control devices. The Baghouse is more rugged and generally better suited for most cement applications because cement applications tend to have a heavy dust load, meaning that for the amount of air that goes into the Baghouse, a lot of dust is going with it. Cartridge collectors work very well in many applications, but when there's a lot of dust loading, it's not always the best. If you're going to use a cartridge collector in cement, it almost needs to be the vertical style where the cartridges hang vertically like bags. If you use the horizontal style, a lot of times the problem is that the dust builds up on the top of the filter and it can't be pulsed off. And then you have like a big mountain on each top of each of the cartridges, and you effectively block off 40% of the cartridge. So if you're going to use a cartridge, it needs to be a vertical one. But generally speaking, for most cement things, you're going to want to stay with a Baghouse because no matter how much dust you throw at it, as long as it's sized correctly, it's going to work very well.
All right, thanks. I have another one for you, Dominic. In a cement plant, does an ESP achieve higher collection efficiency than a baghouse?
So ESP meaning electric static precipitator. Generally speaking, no. ESPs are really only used on really large applications. So we're talking at a cement plant, it'd be like at an actual cement kiln where you have the massive cement kiln, maybe 500,000, a million, 2 million CFM. That's where you would see the larger ESPs. In the past, they were a viable alternative to baghouses when you considered the overall costs and over the life of it and things like that. Basically, they're giant energized plates, and when the air comes in, you ionize the air, and then the particles in the air get attracted to the plates. So it works very well to remove dust without having to use any filters. Over time, though, they haven't quite kept up with the super strict emission standards that apply in some cases now at larger facilities for major sources. So a lot of ESPs over the years have been converted over to baghouses because baghouses still are the best and most efficient when it comes to the absolute collection efficiency. Some smaller applications use wet ESPs where they use water inside of it. Those are comparable to baghouses in a lot of cases, but they don't really, just for a lot of other reasons, they don't usually end up in cement, water and cement dust, obviously not mixing very well. But normal ESPs versus baghouses are almost always more efficient and are required basically according to the most current regulations.
Great, awesome. Okay, so we have another one for Matt. What is a process baghouse dust collector and a nuisance baghouse dust collection system?
Yeah, so a process dust collector, a process baghouse usually means that it's part of the process. So rather than just collecting dust that you want out of the building, out of the way, it's collecting something that's going to be either recirculated back into your process or used in your process. So for example, we recently looked at a copper plant where the material that's being collected by the dust collector is valuable, process output. It's being processed through the dust collector and recaptured. And it might be collected in bags or might be conveyed back into a silo or something like that. But it's not just nuisance dust that you just want to get rid of. Oftentimes we'll see, it might be a silo bin vent or something like that, where you're not trying to just get rid of the dust, you're putting it back into the system. Sometimes you might see a process where there's an actual chemical process that's being done inside of the baghouse, and what's discharged out of the baghouse is part of the product and process. Whereas if you're just talking about dust that's coming off of your conveyor belts, your elevators and so forth that you want out of the facility, with your pickup points, moving it out to a bag house to be disposed of, that would be more of a nuisance bag house versus process bag house.
Great. Awesome. All right. So now question 4. What affects the price of a baghouse filter, Dominic?
So we always say there's like the list of things when we're considering what filters to use. What's the temperature is the first one, followed by what kind of dust you're collecting, followed by what kind of chemicals are taking place in the process. And the last one is the price. So we divide everything first into temperature. So is the process about 260 Fahrenheit or less? If it is, we're almost always going to use polyester filters because they are the most durable, they're the cheapest, and the most easily acquired. If it's more than that temperature, we're going to probably use aramid filters. And the aramid filters are the same thing, but for a higher temperature up to about 400, 425, depending on the exact aramid you use. Things get more expensive with temperature, and then they get more expensive with chemicals and that require treatments and things like that. So if you need acid-resistant treatment, oleophobic treatment, and then later when you need PTFE membrane added to your bags to improve the collection efficiency, improve the dust release, all those things make the bag more expensive. And then one last thing that makes it a little bit more expensive is when we add certain features to the construction of the bag to make it more durable. So the most common ones are adding wear strips, tough cuffs, double disc bottoms, things like that. They're usually on the bottoms of the bags, and they usually are put there with extra material we use so on the bottoms, and it gives it extra resistance to abrasion. So those usually add a few extra dollars if you decide to put those on. A very good investment if you have problems with abrasion. Highly recommended. But yeah, those are the things that make the bags more expensive.
Nice.
And also if you need them, rush, obviously, because very few bags are made and kept in stock. So if we get a request for something like emergency rush service, obviously there's a premium to bump people out of the way of the production queue. So if you want something rush, most bags are about 3 to 5 weeks lead time. So if you want like 1 to 3 weeks lead time, 1 to 2 is usually about maybe a 20% premium. And then in certain cases, we can do, within a week if there's an emergency. And then that depends greatly on the load and things like that. But that could very easily be 50% or 75% extra to rush them out like that.
That makes sense. Okay, good. Number 5, Matt. How often do cement dust collection filters need to be replaced?
Yeah, we get that question a lot. And the answer is it depends, right? So the, you know, how often you change your bags really depends on how hard the bags are being worked, how heavily loaded they are, how difficult your process is. So it really comes down to monitoring the differential pressure across the filters. So in a situation where you're heavily loading the bags, it's a 24/7 operation and those things are being worked continuously, you might have to change them every few months. Whereas in a more lightly loaded scenario, one shift operation, intermittent use and so forth, they might, last for years. But the way that we know when the bags need to be changed is because the DP gauge will tell you when they're blinded. So over time, you'll see brand new set of bags, the differential pressure gauge on your bag house will be very low. It'll start out, at 1 inch, and it'll sort of creep up over time as the bags are cleaned. It goes up and down, but then over time you get up into 5 and 6 inch, range, and the pulse cleaning system can no longer adequately clean the bag, so they're hanging up there in the 5 and 6 inch range on your Magnahela gauge. That's a sign that the bags are nearing their end of life, and they're going to need to be changed, as soon as possible. So what we recommend is people track the differential pressure. You should be checking it daily, weekly at least, so you have sort of advance notice. If you're monitoring your process, you should have plenty of advance notice and be able to predict when those filters are going to reach their end of life. Occasionally, you'll have issues also where the bags will simply fail early, and that could be due to a baghouse design issue or some kind of a process issue, temperature spike, which is less predictable. But if you're managing your process you should be able to, make a graph of the DP over time and see, when you get up into that 3.5, 4.5 range, that, at a certain period of time in the future, your bags are going to be blinded and need to be changed.
Mhm. Good.
I would just add too, you can affect this by the way you operate your baghouse as well and how you maintain it. So a big thing that impacts how long the filters last is if you over clean the filters. So we talked earlier about the importance of doing the baghouses on clean on demand setting where they only pulse the filters when the differential pressure reaches a certain level and then turning off once it's cleaned it down. If you just have it in timer mode, you're increasing exponentially the wear that goes on the filters because most of the wear that causes the filters to reach the end of their life is from pulsing the filters. It's not from the dust hitting them. Also, if you over clean the filters, you have less dust cake on the filters that protects the bags during their operation. So if you blow all that off because you're always pulsing the bags get beat up and have nothing to protect them. So that shortens their life a lot. And then also, if you have the bag house that's either not maintained well or it's too small, that affects how long they last. And then lastly, if you have the wrong kind of filters, so if you just have the cheapo plain ones in there and you have some kinds of chemicals or things like that, upgrading to have certain treatments can extend the life. Or like we were talking about, adding things like wear cuffs and reinforced bottoms, things like that, can extend the life out. So there are some things you can do to extend it a little bit if you make those decisions about maintenance and investing in the right kind of filters.
Great. Thank you. That was a good comment, good addition. Number 6 is for you, Dominic. Can a cement dust collection system be integrated directly into a grout mixing plant?
Um, I think I would need a little more information on exactly what's meant by that question. Maybe the person that that asked that can follow up with us later by email and we can talk about that a little more detailed. But I think maybe what they're referring to is can we integrate dust collection systems directly into like the process machinery? So yes, in some cases you can. Um, Things like blasting machines and stuff like that a lot of times have the dust collector, like the wheelabrator machines, stuff like that. They have the dust collector part built right into the same cabinet, so to speak. Um, in general, in cement and mining and things like that, in the past, I think we mentioned this earlier, there used to be where we would sometimes build in like a modified dust collector into the conveyor belt or the conveyor system. And like we would shorten the filters and put them this way, all this stuff. Um, we don't really go that approach anymore in most cases because those systems don't work very well when they're hacked up and put together like that. It's usually better to have the kind where we have a central system that pulls through ductwork from those kinds of spots. So we have a central. It's also more efficient to have one bigger collector than lots of little ones, in most cases. So yeah, whether to integrate something into the process equipment or to have a separate standalone dust collector, it depends on the circumstance, but yes, in certain cases, it can be done.
Great. Awesome. So I think we have another one, number 7. What regulations govern cement dust emissions on U.S. construction sites? Maybe Matt, would you like to answer that?
Yeah, I'll take a shot at this one. So there's a few things that could apply to your facility. So to start, if you're a manufacturing, mining, or processing facility, the OSHA standard duty clause will apply to you, which basically is very non-specific, but it says you have a duty to protect your employees from an unsafe working environment. And so, following that, depending on your facility type, you most likely will have specific OSHA or MSHA standards, which would apply. And that includes like permissible exposure limits for respirable silica. Depending on the other materials and processes of your site, there might be other standards that would apply. NIOSH, makes recommendations for exposure limits. I think, if you're working with silica dust, you should refer to your MSHA respirable crystalline silica standard. And I know that in the last couple of years, those standards have gotten more stringent. So a lot of facilities that were operating, with looser standards have been forced to adopt new measures to pull dust out of their facility to meet the new standards. And, I won't comment on the specific limits because those tend to change over time, but it's the, required for the facility to be aware of those standards and make sure that they're compliant. So I would refer back to the OSHA standards for your specific facility. If you're a mining facility, the MSHA standards.
Nice. Great. Awesome. The next question, maybe Dominic can give it a shot. How to prevent moisture incursions into our dust collection systems?
So moisture in your baghouse is like the ultimate enemy. So you want to keep it out at all costs. If you have to live with it, then you need to do a couple of things to make sure it doesn't mess up your life. So the first thing is if you have a process where there's some kind of moisture, steam, things like that, you have to design the pickup of the dust collector pickup very carefully. So for example, we have a customer where they're mixing hazardous waste with different kinds of clays and things like that to stabilize the material before they dispose of it in a landfill. And they had a lot of problems because they have a misting system to help control the dust because it's in a big room. But the misting head was right next to the pickup hood for the dust collector. So basically all the mist was just getting sucked right into the dust collector. So seems like an obvious problem, right? But that kind of thing is what we have to design around, make sure we're not unnecessarily sucking up moisture where we don't need to. If you do have moisture that gets sucked up, say, we have a lot of like gypsum and things like that. You have a lot of like kettles and batch cooking and things like that, where you have moisture that comes out, you get steam. You can handle steam and moisture in your dust collection system, but everything must stay warm. You cannot have any condensation. And that's not so much the moisture, it's avoiding condensation. So if you have that, it's actually your friend to keep everything very hot. Most of the time we want to keep the temperature lower, but when you have moisture, you want to keep everything warm. So from the ductwork all the way through to the baghouse and even the exhaust in the baghouse, you might want to insulate. And then many times we even have to add extra heaters like heat tracing or even natural gas heaters sometimes, but that's much rarer. Usually it's heating pads, heat tracing, things like that. And we might even modify the process a little bit so that we run at a higher temperature. Sometimes we adjust how far the hood is away from like a furnace or something like that so that it sucks in less ambient air so that the gas that is going through is hotter. And then the startup and the shutdown procedures become very important for dust collectors. Basic idea, heat the baghouse and ductwork up first and then let the process gas go through. And then when you shut down, you have to purge everything with clean air. So run it with clean air running through it for a few minutes to get all the wet, moist gas out. And then you can turn the system down because then the temperature will go down. And that keeps you from having wet gas in the baghouse and passing through the dew point. So then you don't get condensation. And that's really what the problem is. It's not so much the moisture, it's condensation.
Right. And
Can I piggyback on that? Sorry, Andy.
no.
Just for more general, ambient temperature applications where you just, as a general rule, you don't want moisture getting in your baghouse. Basic maintenance becomes important so that you don't want, if you have a baghouse that's outside, you don't want moisture getting sucked in the access doors and things like that. So basic maintenance is important. Checking your door seal should be a part of your quarterly, if not monthly, preventive maintenance procedures so that you have airtight, enclosure in the baghouse. Doing the same thing for your ductwork, because over time, if you have abrasive dust at a cement plant, you may wear holes in the duct elbows and things like that. And eventually you might find out that you're pulling in ambient cold or moist air, outside of your process into the baghouse. So those are pretty common scenarios where we'll see moisture in the baghouse. Basic stuff like door seals and holes in the ductwork or, flanges that aren't properly sealed, things like that.
Absolutely. Great addition.
Yeah. Thank you for adding those comments, Matt. Excellent. And related to that, maybe you already mentioned on this, Dominic, a little bit, but question number 9, from your experience, what do plants and OEMs struggle with the most in these type of systems? Is it typically airflow distribution, abrasion, and wear, leakage? structural fabrication tolerances, difficult retrofit conditions, maintenance accessibility, or something else. There's so many options.
Um, oh, that's a good one. So in talking about these industries, cement, mining, um, there's a lot of common problems. Some are big, some are small, some are maintenance related, some are design and capital expenditure kind of related. I guess I could maybe mention a few from each category. Maybe Matt, you can get some other ones, but I would say a big problem on a small scale is not having accurate and reliable differential pressure readings. And related to that is the clean on demand versus timer setting. A lot of times that's a result of not having reliable readings. The differential pressure readings are super important because they're the only way to know what's happening in the baghouse. So any discussion about maintenance, optimization, any of that stuff, even emissions as well, what's going out the exhaust stack, for pollution control. All of that, the first question is what is the differential pressure? And then the second one is what is the differential pressure when we do this? So if you don't have reliable readings that you can trust, it's always a suspect. So you never actually know what's happening. It makes diagnosing problems very difficult. A lot of times it's because we don't spend enough time cleaning out the lines and making sure the gauges don't get fouled, and also having the right kinds of gauges that are, rugged, and just maintaining them. So changing them when they get fouled. They get fouled very easily. In fact, we often recommend these little auto blowout devices that we install on a lot of our systems that keep the lines clean automatically, because then you always know what the reading is. The other thing is the reading is on a gauge up 300 ladders, 1,000 feet in the air. Nobody's going to go read that. So it does nothing, even if it is working. For an extra $100 on the cost of the gauge, you can have it send the signal down to the control room and record it on the computer. So why would we not do that? It makes perfect sense to upgrade to a slightly nicer gauge that sends the readings one place. And then the person that used to go and take those readings now can do inspections and preventative maintenance and all this other stuff. So that's a big one. I would say with regard to design and things like that, the number one thing is always the baghouse is undersized because in the quest to get the lowest possible price, there's always going to be some vendor among the 3 or 5 that you get quotes from who will always tell you that their system can do more with less, and that's why it's cheaper. Or sometimes it does happen too. The plants know enough about the system, so they specify they want something that's smaller, more aggressively sized to save costs. For all the different reasons, people might want to have something be lower cost. Once it's in, it's not that it works or doesn't work, it's that it works poorly, works acceptably. Whereas if you sized it the right way, it would work really well. So a really well-designed baghouse, even in cement and mining, is one that you close the door after putting the filters in, you clamp it down, and you don't open it again until 1, 2 years later when you change the filters. And that's the only time you open it because it has no problems otherwise. When it's too small, you're in there all the time. You're getting holes in the filters every month or two. You're not getting in. You're getting like 80% of the suction you need, right, at the pickup point. So it's getting most of the dust, but there's still dust on the floor. It's still dusty in the plant, and that's what a lot of sources. So I'd say that's probably the biggest big picture thing is systems are too small, undersized for the application, or they were the wrong type of model. Like someone bought a cartridge collector and they should have had a baghouse. Those kinds of things.
Yeah, I'll add to that because we've been in so many facilities and all of these things happen. There's all of these symptoms are present, but the thing that seems like most facilities nowadays have trouble with is just the fundamental maintenance because for you have to train your maintenance and your operations staff on all the fundamental baghouse inspection maintenance procedures, right? And so when you have a lot of churn, it's hard to keep people, you lose that every few quarters, when you have a new batch of maintenance staff. And so those new people may not know the fundamental, what to look for. Like Dominic said, the DP gauge, nobody knows to look at it. So it just goes, it goes and gets worse and worse, and then all of a sudden there's issues in the facility and people are wondering why. So I'll use this opportunity to kind of plug our services. We do a lot of on-site inspection maintenance services. I would recommend you do that once in a while, if not on a quarterly basis, just to make sure that those things are being addressed. And then over time, these type of facilities have a way of changing over time. Processes get moved around, pickup points get added, often for good reason, right? Because, you have a new machine over here, you need to reroute this ductwork over there. And we'll go in these facilities where the dust collection system may have been perfectly designed to start with, but things have changed. Ducts have been added, pickup points have been added or moved or closed off. And then you have balancing issues in the ductwork. You've added pickup points and sort of watered down the airflow at each of the pickup points where you need it. And people are then kind of left scratching their head as to why, it's so dusty in the facility. So the other recommendation I would make is if you're planning to change to your facility, if you're going to add a machine or remove a machine or make any kind of change to the ductwork, the layout, and so forth, you should look at the dust collection system, have someone who's familiar with the system look at it very closely to make sure that you're going to have enough filter square footage, enough fan capacity, and that the ductwork system is designed properly so that you don't have issues as a result of that. So those are just two common things we see. All of the issues that Ian mentioned, Andy, airflow, distribution, abrasion, all that stuff plays into it. But if you can make sure your maintenance staff is trained to kind of recognize the symptoms, or you get, an outside expert like us in there every once in a while to take a look at things, you can address them before they become systemic, chronic issues in your facility.
Nice.
Yeah, I would just add it's always the small things, it's the basics. People always think we're going to come and find some like crazy complicated thing that requires a team of engineers to solve and millions of dollars. The vast majority of what we find when we do inspections and that's in our reports, it's lots of these little things that we mentioned that can be resolved with better training or just attention and resources dedicated to it from the maintenance operations team.
Yeah, most of the reports are like basic stuff. Door seals, pulse valves, fix the leaks here, things like
Change
that.
the filters.
Yep.
That's true. Thanks, guys. Thanks for that answer. Okay. Question 10. We have 5 more. How do I deal with corrosion inside the baghouse? Dominic, would you like to?
Most corrosion is from condensation, from moisture coming out. So all the things we mentioned before, making sure you have no condensation anywhere in the system. What Matt said is very true, though. The vast majority of corrosion in any baghouse, if you go up, it's always around the door, around the airlock, and around the flanges of the ductwork. And that's because those are the places the gaskets get worn out and air leaks in. So you have cold, wet, humid air outside leaking into the hot air. So you have condensation, or vice versa. When it's winter, you have cold air that goes into hot gas, and that's where you get the condensation. So making sure the door gaskets and all that are in good condition, there's no holes. And just one other detail that gets overlooked a lot of times when we go to open the baghouses and the bolts are just finger tight. So they have the good gaskets, but they don't appreciate that they have to really clamp the door down. And that's where the leakage is because they're not clamping it down.
Yeah, just to add to that too, you mentioned already, making sure your temperature is high enough so you don't get, condensation. And then I'll add one other thing. We recently have partnered with a company called Eon Coat that makes a ceramic coating that you can apply to steel structures like the interiors of baghouses. And it's a extremely high temp and extremely corrosion resistant coating. So we've had a recent, application that had a lot of hydrofluoric acid along with high temperatures, very challenging, super aggressive corrosion on the baghouses. But this coating you apply basically, and it lasts for years if it's done properly and maintained, and it resists corrosion. So in a super challenging application where you just cannot manage the temperature, or you have some aggressive acids or chemicals in there that are going to attack your structure, something like that could be an option as well.
Nice, Matt. Excellent. So I have another one for you, Matt. What is respirable crystalline silica, and what is the acceptable occupational exposure for RCS, or respirable crystalline silica?
Yeah, respirable crystalline silica is basically silica dust, but it's so fine that it can be breathed in, or it's respirable, and it's of a certain size. The standard is so small that you typically cannot see it as airborne dust, but you can breathe it in, and it can cause all kinds of problems. Like, there's lung conditions that are specifically attributable to respirable silica dust. And so the reason it's regulated is because it's dangerous. You can give yourself lung cancer due to repeated exposure or chronic exposure, or even, single instances of like high dose exposure. So I won't comment on the specific limits again, because they tend to change, but you need to check if you have silica dust at your facility, you're almost certainly, regulated by the OSHA and MSHA exposure limits for respirable silica. So you got to check the regulations and make sure you're compliant. If you're not sure, you need to go do some testing with the sniffer and make sure you know what's going on in your facility, and design a dust collection system so you can get that out of the facility.
Nice. Okay. Dominic, how do I prevent ductwork clogging and hopper breaching in my cement plant? What would you say?
So for the duct work, the name of the game there is making sure the air moves fast enough that nothing falls out. So the air needs to move at or above a certain speed we call the minimum conveying velocity, to keep the dust particles entrained or floating in the air as it moves through the ductwork. If it goes any slower than that, the dust will start to settle and fall out, and then it'll start to build up and you get plugging. But before you get it plugged or clogged like that, the problem has existed, and that's why it's been building up. So related to what Matt said earlier, many are surprised to find out that the ductwork is actually the thing that requires the vast majority of the engineering time. Not the baghouse, not the fans, it's the ductwork. It's the thing that most people have backwards. They usually think the ductwork is like the dumb part of the system. But getting it the right size is important, because we're artificially making it small, so to speak, so that the air moves really fast inside. That's why for the volume of air we move, the ductwork is relatively small compared to like HVAC ductwork, which moves a fraction of the amount of air, but is the same size or larger than our big industrial ducts, right? So making sure all the parts of the ductwork system are sized correctly. You can't simply connect another hose or another line on. You can't simply close one off here and put another one on, because everywhere two ducts come together, the duct needs to get bigger, and like a tree trunk, and then the next branch comes on and it needs to get bigger. And if you change any of those things around, you will have buildup that basically starts happening. Or you can have the opposite, which is where the air goes too fast and you have a lot of wear and things like that. In the hoppers, bridging is a big problem with a lot of materials. That comes down to the kind of dust that you have. So some things are stickier, tend to agglomerate more than others. But a main thing with thinking about the dust collector part of it, big thing is not storing dust in the hopper ever. So as soon as dust is blown off the filters, pulsing, whatever dust falls in the hopper should hold that dust basically until the next pulse, and then that's it. So you pulse one row of bags, whatever falls down, the airlock or screw, whatever you have on the bottom, should remove all of that dust, and the hopper should be completely empty before the next bags are pulsed. So basically the hopper never stores dust. A lot of the bridging and all that stuff happens because we have an idea that the hopper, because of the name, which is a very bad name for it, is supposed to hold material. It's not. Absolutely essential. As soon as dust is blown off, you remove it out of the hopper. That goes for at the end of the day. We start up, it needs to be empty. And that's all the more important when you have materials that have the potential to bridge like that and stick together.
Can I add one thing to that? Talking about the ductwork, since we're talking, cement applications, one thing that's pretty common in like crushing, part of the process in particular, you'll see a lot of cement plants have this grasshopper leg style ductwork. And that's pretty common. And the idea there is to basically ensure that the heavier stuff that gets pulled off your conveyor hood falls back into the process while the lighter dust goes up into your ductwork. So you want to make sure that the ductwork itself is sized properly to keep the lighter stuff flowing. But you'll see those grasshopper legs, which are designed so that when your system shuts down or for whatever reason, you don't have dust settling. And when the system turns off, usually you're collecting all the fines through the ductwork. The heavy stuff kind of falls back into the process. There are some challenges, some issues with that style of design, so it needs to be done carefully in specific applications. But it's very common in cement plants and heavy kind of crushing applications and things like that. And then another good practice is just to have clean out doors and access panels in your ductwork, so that as part of your quarterly inspection process, you can go look in your ductwork and see if you're getting dust settling, vacuum it out if you need to, and just make sure you're keeping tabs on it before it becomes a big issue.
Nice. All right. Okay. And since I have you there, Matt, the question 13, how to monitor air quality in a cement plant? What would you say to that?
So there's a few different things that could mean. So just as a general, what's the air quality inside my facility? There's air quality monitors that you can use and sniffers, and there's various different devices. Some of them you can carry them around with you. You can connect them to your phone or clip them on. They're basically just air quality monitoring, real-time measuring device that will tell you the exposure and the air quality and how much dust is in the air and so forth. So just to get a baseline of what's in your facility, you can start with that. There's all kinds of sensor options. We have Dust IQ, which is kind of an IoT connected sensor system or operating system. So you can add air quality sensors wherever you want in your facility. If you want them to, have a dashboard showing it in real time, what's the air quality, how much dust is in the air at any given moment, we can do that, and we highly recommend it. There's also, quality sensors and particulate sensors that you can put in your ductwork on your fan exhaust, so you can see if you're getting dust bypassing the filters, prior to having a visible emissions issue or you have to shut down. You can put sensors in particulate sensors and broken bag detectors in your exhaust duct to give you a warning if you're starting to see, air quality issues on the clean side of the baghouse.
Great. Awesome. And the last question, Dominic, here it says, how to control fugitive dust emission in our cement plant? They said that they are already using baghouses, ESPs, and dust suppression methods, but the problem still persists. What would you say?
I would say you need to have someone like us come out and review your plant, see what the problem is. But I think the general idea is probably something that a lot of people maybe feel, experience at their plants. So they feel like they've got everything. Why is it still such a mess? Or the other way, it could be a lot of people kind of just are resigned to the fact, oh, I work in this industry, it must be dirty all the time. We have one of our customers, mining minerals, things like that. For many years, the plant culture, the company culture was that this is a very dirty job and you go home completely dirty every day. And then after some new ownership came in, doing the same thing at their plants, they were spotless. And it's been taking many, many years to change the culture to the idea that no, you can have the same process and do it, and the plant be relatively clean, right? So a lot of times, if you have all the equipment and the plant is still very dirty, a lot of times it's like we said, these smaller things. It's the ductwork that has been modified a million times over the years, and now everybody just assumes that's as good as baghouses work. They suck up most of the dust, but the area around that machine is always going to have dust all over the place. But that is not a adequately functioning baghouse. That's like a chugging along baghouse that's just barely alive, right? When it's designed correctly, maintained correctly, and operated correctly, dust collection systems will get 99.99999% of all the dust that's generated from something. So there's no reason you have a Raymond mill, there's no reason you have kettles, if you have belt conveyors, crushers. None of those machines are incapable of being clean around them you have the dust collection designed right. So it might be redoing the duct work, might be that too many things have been added onto it, so you got to remove things and make sure the full power of the system is going to the pickups as it's intended. Or it's just maintaining it again. Sometimes we go and they don't change the filters, or they change them every 10 years, and they think that's normal because they don't have the DP gauge telling them it's 10 or 12 inches. They see a broken gauge with water in it, and it says 1 inch, and they go, "Oh, well, our air permit says less than 5, so we must be good." And then you put a new gauge on, and you see it's actually like 10, 12, so there's no suction basically through the system, right? So it could be a lot of different things. But this is where, when we come into our inspections and then our training, a lot of times plants are able to finally figure out the problems. It's not because we're so much smarter than everybody and all this. And it's not that the plants are so negligent or anything like that. It's just you need somebody sometimes to come and point out things in a very specific way and then lay out a roadmap that you can follow. You just don't have the bandwidth to be making cement, to be working in mining, doing all the things you're supposed to do, and then somehow also be experts in dust collection. So having us come, find all the little problems, lay it out, and give you a pathway to fixing them all. Many times that's all it takes. And then what you have is fine. You don't need to buy new equipment. You just need to use what you have adequately and maybe show a little bit more care to it, and then it'll work just fine.
Great. Thank you, guys. Thank you. Great questions and excellent answers. Thank you so much. All right. So thank you, everyone in the audience, for staying with us. We appreciate your attention, your participation. Many of you participated with questions as well. So thank you so much. As we mentioned, you'll receive a link to watch the webinar. And if you think that somebody might benefit from this content, you can forward that link so they can watch it whenever they are available. So on behalf of all the team at baghouse.com, we thank you again, and we are at your disposition. If you need anything, just call us or email us. If you have any additional question regarding what we analyzed today. All right, so have a great rest of the day. Bye.